This is pre-calc section 7.2 on ellipses and hyperbolas. It's going to take multiple videos to get through this whole lesson. So this is an ellipse. An ellipse looks like a football or an oval. And the definition is it is a set of all points in a plane, the sum of whose distances from two fixed points is constant. Each fixed point is called a focus, and the plural of that is foci. And what that means is here's one of the foci, here's the other one. If I pick any random point on the ellipse and I go from focus to that point, measure that out, and from that point to that focus, whatever that distance is, let's just call it M, then any other point I go from to the focus remains that same sum of M. If I go from this point down to the focus, that point down to that focus, and add them up, it comes out to be a distance of M. If I'm down here, from here to the focus, plus here to that focus remains a distance of M. That's the definition of ellipse. It is the set of all points such that those sums remain constant. Now, the ellipse has two axes of symmetry. It has what's called the major axis, which is the longer axis. That makes sense. Major is the longer, and the minor axis is the shorter one. The foci are always located on the major axis. So whichever axis is longer, that's where you will find your foci. The midpoint of the major axis, which would be right here, is the center. And the endpoints of the major axis are called vertices. Singular is vertex. These points right here are not called vertices. They are just called endpoints of the minor axis. So the standard form of an ellipse is x squared over a squared plus y squared over b squared equals 1. It has to equal 1 to fit the standard form of the ellipse. A is the horizontal distance from the center to the endpoint. So for this picture right here, this distance right here is A. So is this distance right here. Those distances are A. Those are the horizontal distances. If I measure from the center up and the center down, those are vertical distances, and those are B. And then C is the distance from the center to the foci. Remember, each focus is located on the longer axis, so from here out to here is a distance of C. I always let A go with X and B goes with Y. This is different from the way the book teaches it. I've just always let A go with the horizontal and B go with the vertical. One reason to do that is that will minimize the number of formulas you have to memorize. But this way, you have to understand what you're doing. And what you need to understand is A, right there, which is underneath X, refers to the horizontal distance. B, which is underneath Y, refers to the vertical distance. And then C is always the distance from the center to the foci. Now, you're going to be able to look at the equation and name A and B very easily. To come up with your C value, it is kind of like Pythagorean theorem, but instead of it being A squared plus B squared, it's minus. Also, sometimes it's A squared minus B squared. Sometimes it's B squared minus A squared. And all you need to think about is it's the larger value squared minus the smaller value squared. Determining if an ellipse is vertical or horizontal depends on the size of the denominators. If A, which is the horizontal value, is greater than B, which is the vertical value, then it's going to be elongated horizontally. Think about that. If A is bigger, you're counting further out horizontally, and that's going to make the ellipse be elongated horizontally. Now there's your standard form. To come up with your C value, it's A squared minus B squared, and the reason it's in that order, A squared minus B squared, is because we've already established that A is greater than B. The center is 0, 0. This is like what we had with the circles a little while ago. There is nothing up here with X, nothing with Y. That's what makes the center 0, 0. Now this is all stuff you could memorize if you wanted to, but I'm going to show you a way to do this that doesn't require a lot of memorization. We know that the center is 0, 0. We also know that this is a horizontal ellipse. My suggestion is as soon as you establish that it's a horizontal ellipse, you underline the horizontal component of your center. Because if it's horizontal, you are going to find the vertices and the foci by doing something to the horizontal component of your center. So why are the foci plus or minus C0? Well, the C value, the foci, are located on the major axis. It is elongated horizontally, therefore the foci are on the horizontal axis. And where this plus or minus C comes from is that we are counting out from the center. We are counting out C in a positive direction. We are counting out C in a negative direction, so that your foci are plus or minus C, comma 0. The C is getting tacked onto that component. So one way to think about this is it is 0 because that's where you started, and you are tacking on C on top of that. The y part of the center stays what it was, which was 0. And of course, if you clean up 0 plus or minus C, that's why it stays plus or minus C. Now, the vertices are always on the major axis. To find the vertices, you are starting at the center, and you are counting out A units to get out here, counting A units to get out here. So you can think about taking the A value now and tacking it onto the horizontal component of your center. So that is 0 plus or minus A, comma 0, which, clean that up, just gives you the plus or minus A. And this is going to make more sense when we finally have some numbers and you do enough of them. Now the endpoints of the minor axis, because it is elongated horizontally, that makes this your minor axis. That is the vertical axis, and that is why the B is getting tacked onto the y part of your center. So that's 0, comma, plus or minus B. So let's take a look at a whole problem and see if we can do this reasoning. You are welcome to memorize those formulas, but it will turn into a lot of formulas to memorize. So let's see if we can do this from a reasoning standpoint and from a graphical standpoint. Using the graph can help you out a lot too. So here's our standard form. I need to get this rewritten so it looks like this. I need it equal to 1, and the way to get it equal to 1 is to divide everything by 36, which gives me x squared over 9 plus y squared over 4 equals 1. So that's your first step. You've got to have it in standard form. The second thing you need to do is identify what type it is. It is a horizontal ellipse. We have not talked about vertical ellipses yet, but this is horizontal ellipse because the A value, the value that is underneath the X, is bigger than the value underneath the Y. So the center is 0, 0. Now let me go back to the directions for a second. It says graph the ellipse and find the foci, vertices, domain, and range. It didn't say find A, B, and C, but if you don't find A, B, and C, you can't find those other things. So A is the square root of that number right there, which is 3. B is the square root of that number, which is 2. Remember, the A value is always underneath the X. The Y value, or the B value, is always underneath the Y. Now to get C, it is bigger, take away smaller. Do you really have to write A squared minus B squared? No. Take a look at what you have, which is bigger. 9 is bigger. So do 9 minus 4, which is 5. But you got to remember to take the square root of that. So the C value is the square root of 5. It is a horizontal ellipse. Underline the horizontal component of the center so that your foci, the foci, see the C of foci? To get the foci, you're going to use the C value. So you can actually even draw an arrow up here. You are going to tack on plus or minus radical 5 to 0, which I could write 0 plus or minus radical 5, but because that is a 0, I am just writing plus or minus radical 5, 0. Now, why is it going in that position? It is going in the horizontal position because it is a horizontal ellipse. To find your vertices, you will take your horizontal value, which is A, and tack it onto your horizontal part of the center. So this would be 0 plus or minus 3. So this is just plus or minus 3, comma 0. Now we'll do domain and range once we have the picture drawn. So our center is 0, 0. A equals 3 means count out 1, 2, 3, and put a dot. Count 3 in the other direction and put a dot. 1, 2, 3, put a dot. B is 2, count up 2, count down 2. And then try to connect your dots. I can really not make a curve too well. So it should be more curvy, not straight lines. So just from there, I could fill in these values right here. And it's not a bad idea to put them on your graph because it will help you do your domain and range. So this is the point 3, 0. This is the point negative 3, 0. And what are those? Those are vertices. Why are they vertices? Because they're on the major axis because this is a horizontal ellipse. So that verifies what we did right there. So you could get your graph first if you're pretty neat with your graph. To get your endpoints of the minor axis go up 2. So this is up 0, 2. And this is 0, negative 2. Now, I didn't ask you for those in my little list right there, but the reason I'm putting those on the graph is that they will help me get the domain and the range. The domain is your x values from left to right. So this is negative 3 with a bracket out to positive 3. Your range is low to high, so from negative 2 up to 2. So if on MathLab you keep clicking similar exercise, you should get pretty good with naming this information. Now, all the information for a vertical ellipse, very similar, but you're going to have to put things in the correct position. If b is greater than a, it is a vertical ellipse, because if b is greater, that means it is elongated vertically. To find your c value, it is b squared minus a squared, but you could look at it as just bigger squared, take away smaller squared. The center is still 0, 0. The major axis is vertical. The major axis being vertical means this is your major axis, and your foci now will be located on the major axis. Your vertices are on the major axis. There's your vertices right there. And the endpoints of the minor axis are here. Now let's see where these letters came from. Well, your foci, using the c, that means your c value is going to need to be tacked onto the vertical component of your center. So if you put c right up in there, plus or minus c, there's your 0, comma, plus or minus c. To do your vertices, same idea, but you are putting b in that position. And then the endpoints of the minor axis, you are using the other component. You are using the horizontal value, which was the a. So let's take a look, and it will make more sense with numbers. Here's your standard form. We need to get this into standard form, and the way to make that happen, divide everything by 64, which gives me x squared over 16 plus y squared over 64 equals 1. Because the value underneath the y squared is bigger than that value, that tells me this is a vertical ellipse. The center is 0, 0. The reason the center is 0, 0 is because there's nothing up here with x and y. Because it's a vertical ellipse, I would underline the vertical component of your center. Then we can name these a, b, and c values pretty easily. A is 4, b is 8. To find c, I need to do bigger, take away smaller. So that's 64 minus 16, which is 48. But it's the square root thereof, which simplifies into 4 radical 3. So those are your a, b, and c values, which you will need to find this information. You could start your graph right here before you name these things, and for some people it's helpful to do that. So here's your center of 0, 0. My a is 4, 1, 2, 3, 4. 4 in this direction. B is 8, 1, 2, 3, 4, 5, 6, 7. I got to just go out here a little bit. So same thing here. This is going to end up down here. And then I can connect my dots. And there's my ellipse. Just from that picture, that verifies, yep, it is a vertical ellipse because it is elongated vertically. Now, where are the foci? The foci are on the major axis, so they're in here somewhere. How do you get those foci? Well, because it is a vertical ellipse, the c value is going to have to get tacked on to the vertical component of your center. So this will be 0, comma, plus or minus 4 radical 3. To get your vertices, because it is a vertical ellipse, we use the b value going into that same position. So your vertices are 0, comma, plus or minus 8. So let's name these values right here before we do the domain and the range. This is 4, 0. This is negative 4, 0. And those are what's considered endpoints of the minor axis. This vertex is 0, negative 8. And this vertex is 0, positive 8. Now to name your domain and range is pretty easy from left to right. This goes from negative 4 to 4. And your range from low to high goes from negative 8 to 8.